What if the moon broke apart? Imagine if it split into pieces like Mimer's almost did, giving it that Death Star look. Would Earth be much different if we had a bunch of little moons instead of just one? What changes could we expect on Earth? And how would our night sky transform if our single, faithful lunar companion were to undergo a cosmic division? Join us on a journey of speculation as we delve into the intriguing question: what would happen next if the moon were to split in two? Relation of Earth and Moon. As celestial companions, Earth and the moon share a harmonious relationship. The moon's gravitational influence orchestrates the rhythmic dance of tides around our planet, creating a predictable cadence in our daily lives. Due to the phenomenon of tidal locking, we are accustomed to seeing only one face of the moon. If the mysterious dark side were somehow lost, the immediate impact might not be readily apparent. However, the question arises: could the severed half gradually drift away? Over the course of millions, even billions of years, if the gravitational forces between the two halves allowed for a slow separation, the fragmented moon would eventually assume spherical shapes under the relentless influence of gravity. Such a transformation could leave Earth adorned with two smaller moons, a celestial spectacle that would undoubtedly evoke joy among enthusiasts of galaxies far, far away, echoing the iconic imagery from the Star Wars universe. Changes that might occur. Many individuals are unaware that as the Earth rotates on its axis and the moon orbits our planet, a fascinating interplay unfolds between these celestial bodies and the oceans. This dynamic interaction is responsible for the phenomenon of tides, where the gravitational pull of the moon causes the oceans to bulge towards it, while the continents experience a reciprocal effect, colliding with the rising tide. It's speculated that this tidal force is a contributing factor to the gradual slowing of Earth's rotation over time, transitioning from a 6-hour day to our current 24-hour day. Law of angular momentum and effect on biological rhythms of Earth. Another significant influencer on Earth's rotation is the law of angular momentum, a principle akin to observations made at a skating rink. Just as a spinning skater slows down when extending their arms and speeds up when bringing them closer to their body, the same principle applies to the moon, analogous to the skater's arms, and the Earth, representing the skater's body. As the moon gradually moves farther away from Earth, a process ongoing over geological timescales, Earth experiences a corresponding slowdown in its spin. However, introducing the concept of lunar, a hypothetical scenario where half of the moon's mass is suddenly pushed closer to Earth, adds a captivating twist to this celestial ballet. In this scenario, the planet's rotation would undergo an acceleration, causing a disruption in the established day-night cycle. A halved moon would bring about partial solar eclipses, specifically known as annular eclipses. The implications extend beyond astronomical curiosity, potentially influencing the biological rhythms of Earth's diverse array of animal life, as the pace of the planet's spin plays a crucial role in shaping their daily patterns. With reduced mass, the moon would gradually draw closer to Earth, potentially appearing larger in our night sky despite its diminished size. The weakened lunar gravity would result in smaller tides, impacting marine ecosystems within the intertidal zone, the region between high and low tide levels. The livelihood of sea turtles, seabirds, and fish could be jeopardized as the predictability of tides, crucial for activities like feeding, egg-laying, and migration, becomes uncertain. The moon's gravitational influence on Earth goes beyond merely shaping the tides. It plays a pivotal role in stabilizing our planet's rotation and maintaining the consistent 24-hour duration of our days. The moon's reduced gravitational pull would exert less drag on Earth, diminishing the counterforce that slows down its rotation. As a consequence, days would be significantly shortened, potentially contracting to a duration of 15 hours. This seemingly subtle shift in the length of days carries profound implications for various aspects of our daily lives. Night shift workers, whose schedules are meticulously designed around the 24-hour day, could face a considerable challenge. The abrupt alteration in the length of a day might necessitate a reevaluation of work hours, potentially leading to adjustments in pay structures or requiring adaptation strategies for those accustomed to nocturnal schedules. Moreover, beyond the realm of human activities, such a fundamental change in Earth's rotation could disrupt ecological systems and natural processes that have adapted to the established day-night cycle. Plants, animals, and ecosystems finely tuned to the existing 24-hour rhythm might face challenges in adjusting to a condensed time frame, potentially impacting behaviors, reproduction cycles, and migration patterns. Axial tilt and its effect on weather. Moreover, the gravitational interplay between the Moon and Earth extends its influence beyond the familiar tidal forces, exerting a stabilizing effect on our planet's axial tilt. This axial tilt, currently at approximately 23.5 degrees, is a critical factor governing the seasons and the overall climatic stability of our planet. However, delving into the speculative scenario of a halved moon introduces intriguing dynamics that could cascade into significant alterations in Earth's axial orientation. Under normal circumstances, the Moon's gravitational pull helps maintain the stability of Earth's axial tilt, preventing excessive wobbling. This stability, in turn, ensures a relatively consistent seasonal cycle, with predictable transitions between spring, summer, fall, and winter. However, if the Moon were halved and its gravitational influence diminished, a consequential reduction in the stabilizing force on Earth's axial tilt could ensue. The implications of such a change in axial stability would be profound, leading to shifts in the timing, intensity, and duration of seasons. The familiar climatic patterns that ecosystems, flora, and fauna have adapted to over millennia could undergo significant transformations. Regions accustomed to temperate climates might experience more extreme and unpredictable weather events, while areas near the poles could witness more pronounced variations in daylight and darkness. Drawing parallels to the Martian climate offers a compelling analogy. Mars, with its two small moons, Phobos and Deimos, exhibits a degree of axial wobbling. This phenomenon induces erratic weather patterns, marked by dramatic temperature fluctuations and high winds. Similarly, on Earth, a diminished moon could lead to a less stable axial tilt, potentially resulting in climatic variations reminiscent of the red planet. In practical terms, altered seasons and temperature variations could pose challenges to agriculture, disrupt natural habitats, and impact biodiversity. Ecosystems finely tuned to the existing climate patterns might face difficulties in adapting to the new normal, potentially leading to shifts in species distribution and migration patterns. Debris and collisions. If we were to cut the Moon into two, a significant consequence would be the generation of debris in space. Imagine breaking a piñata and having smaller moon pieces scattered all around. The Moon's gravity plays a crucial role in keeping things on its surface. Cutting it into pieces would alter the gravitational forces at play. Some debris might drift away, while others could be drawn toward Earth or other nearby celestial bodies. This change in gravitational influence could have a cascading effect on the behavior of the lunar fragments. The presence of lunar debris in space would pose a potential hazard to our satellites and spacecraft. In orbit around Earth, satellites follow specific paths, and any unexpected obstacles, such as moon fragments, could disrupt their orbits or lead to collisions. Protecting our valuable space equipment would become a paramount concern, requiring new strategies and technologies to navigate through the increased risks. Moreover, the challenges wouldn't be limited to Earth's orbit. Lunar exploration missions would face complications as well. Navigating spacecraft through a field of lunar debris would be akin to driving a car through a rocky field. A very careful and strategic approach would be necessary to avoid collisions and ensure the safety of missions exploring the Moon. Night sky aesthetics. Lastly, the Moon holds a prominent place in the canvas of the night sky, influencing the aesthetics that humans have marveled at for centuries. The division of the Moon into two distinct pieces would undoubtedly reshape the visual narrative of the night. The lunar phases, a poetic dance of light and shadow, would evolve into an entirely novel spectacle, as the separated halves might present varying shapes and sizes during their orbits. This alteration in the lunar landscape could impact cultural perceptions deeply rooted in celestial observations. Across cultures, the Moon has been a symbol of time, rhythm, and change. Its waxing and waning have inspired folklore, traditions, and religious practices. A divided moon would introduce a new chapter in the night sky story, challenging established interpretations and inviting fresh perspectives. Cultural rituals and celebrations tied to lunar events, such as full moons or eclipses, might take on new meanings. The symbolism attached to a complete, unbroken moon could contrast sharply with the fragmented reality, prompting societies to reconsider and adapt their narratives surrounding these celestial occurrences. In essence, splitting the Moon into two wouldn't only alter the physical appearance of the night sky, but also reshape the cultural and symbolic dimensions associated with this celestial body.